heading the engineering work for Choreo product. And then I'm also passionate about the developer experience side of the platform. So that is what we are going to talk about today. So the topic, how internal developer platforms enable developer self-service. What is internal developer platform? Nuwan explained in great detail in the earlier session. So to explain the topic, let's go to the boring definition of what is developer self-service. So I took this from the Puppet blog. Developer self-service describes automated tools and processes to empower developers to work without help. The part I want to highlight is empower developers to work without help. That is where we should target with developer self-service. With that in mind, I'm picking up, I'm giving a different definition for that. We have been talking for a long time, so to keep things interesting, developers are architects, creators, magicians, or like Jedi who create these digital experiences for your customers, right? And developer self-service in a parallel universe is like giving them the force, giving them the ability to go and create these digital experiences by themselves, from provisioning environments, resources, to deploying and also getting the logs of the production environment as well. So that is an alternative explanation to what developer self-service. And then with that, I'm going to use this scenario for us to move forward. So in these days in Sri Lanka, there's a huge push for private banking offerings. Anyone in the audience from Sri Lankan banking sector? All right. Yeah, you know what I'm talking about. So there's a great push these days for private banking offerings. So I'm going to pick that scenario. So we have we are modeling two banks. They want to offer these private banking offerings. And so they have the need to go to market first to capture the limited prospects. Not everyone would get selected for a private banking offering. And in this case, we are using two developer profiles, Arakin and Luca, representing two banks tasked to develop an API to return existing high-net relationship clients. Yes, I know the names. My marketing team asked me to change it, so I changed it to Arakin and Luca. Net relationship criteria is, in this example, the sum of investment account balance and the lending account balance. If you have higher than this amount, you are eligible for the private banking offering. And I throw in another requirement, they have to need to persist the monthly report as well. So this is the scenario that we are going to move forward to the rest of the presentation. So with this scenario in mind, a very high-level L1 kind of architecture that you can come up with. You have your net relationship balance service, the new one that you are going to implement. And then you need two dependencies to get your lending balance and your investment balance, and then a DB to persist your monthly report. A very simple L1 architecture for the sake of argument. And then let's look at how these two developers are going to go forward with that. So we are going to follow their developer journey, touching upon four key principles of four key capabilities of developer self-service. So first one is dependency discovery. So dependency discovery is basically now the Arakin and Luca needs to figure out where to get that investment account balance and the lending account balance. So Arakin, the developer profile is, he's coming from a legacy mega bank with a proven but aging platform with a lot of red tape and processes. And Luca is coming from a more agile, newer bank which employs the internal developer platform. Those are the two developer profiles. In a parallel universe, Arakin is this megalithic empire using his imperial engineers to get the things done. Luca using his self-serviceable RTD2 droid to get things done. So those are the two synonyms. So what can Arakin do to get the dependency discovery done? I'll list few options. First one is ask around, as Nuwan said earlier. You go and talk to that engineer who has been in the company for 15 plus years, like Aziz over there, and say, how can I get these two resources done? And then another thing is you go ahead and search in a source code in a component that is likely to do the same thing that you are doing, get the dependency done from there. Or else, if you're a more structured company, you have your internal documentation somewhere, you go search and there, get it. And then another step forward is using heterogeneous portals. Like you will have a proper API manager deployment. then you would be having API descriptions over there which you can go through and search, or cloud provider portals. Each and every option of these will get the thing done. It's offering some kind of a developer self-service. But we will look at how internal developer platforms are redefining this developer self-service. So on Luca's side now, in internal developer platforms, the vendors and even the self-built one offer this service catalog. So service catalog is a collection of all the services and resources that is being offered and deployed within your organization that you can freely use. That is a catalog of that. And in internal developer platform implementations, these catalogs will have automated dependency additions. That means if you deploy a new service within your organization, that would appear in your service catalog so that others can see that. And they would have searching and filtering capabilities, a proper searching and filtering rather than you going through the text. And they would be context aware. If you are searching from within one project or a domain, it would show you the resources and services available in that domain for you. And it would also give you developer tool integration. You don't have to look into go into some console and look at this. It will be integrated into your VS Code or your favorite idea for you to search as well. So these are some capabilities offered by internal developer platforms to make the argument more solid. We are using Choreo as the reference implementation of an internal developer platform, and I'm going to show you examples from Choreo how that service catalog dependency discovery is done. So this is a screenshot. It's pretty blurry for me, but what this is our service catalog. We name it as the internal developer platform. In this area, you have the services that are available for you to consume, and then you can have multiple services available there. You have services, database, and multiple resources there. You have the filtering capabilities over here, and you will have searching capabilities over there. So you can search and filter your resources. And in this case, Luca will come and find the investment banking backend over there. And once he dives inside that, they can go and also check the API definition and see whether that dependency suits the need of his development. Once that is done, the platform will offer a capability to connect to that service as well. Give it a name and a meta concept of connection where you can say, I want to connect it at this level, organization level, or from the public internet, and I want to use this security mechanisms. And then after the connection, the platform itself will give you your service URL and the API key for you to use, and information on the other side in a way integrated that you can give this meta tag in your source code, where a platform will now inject your service URL and the API keys as environment variable, so that you don't even have to copy paste. So this is one reference architecture implementation from Choreo. Different internal developer platforms will choose to do this in different way. The point to take home is it's all integrated in a self-serviceable way. Now with that capability, now our architecture diagram is looking like this. You have your get lending balance and get investment balance services figured out now. To support that in a self-serviceable way, in a very conceptual manner, you at least need these components where you have your CD pipeline which deploys these services, but also publish them into a service catalog. That service catalog service will keep the definition of the services in a DB and offer that to your developer portal, which will give you the searching and connecting capabilities. So that is how our architecture diagram is evolving. From here, we will look at the advantages of providing this kind of dependency discovery. So you have now ready-to-use information, your service URLs, API keys, and everything, and less cross-team interaction. You don't have to go ahead and find the guy or girl and ask for the URLs. You have configuration governance, because now the system is providing you the URLs and everything that you need to connect. How to feed that system is governed. It's not a Confluent doc or a Google Docs as somebody has written. It's governed. and because there's no copy pasting, less human errors. With this, we are moving on to the next step. Now the dependencies are figured out. Now you need to figure out the database, provisioning. So next up is provisioning. In Arakin's case, I'm going to make 3 simple options. You send an approval email. I want this database. Can you please approve? And then your DevOps or SRE platform engineering team get to the database. Or you have implemented a ticketing system. You submit your ticket, wait for them a day, half a day, 3 days, and you get your database done. Or in some cases, your developers have been empowered to write your own IAC, infrastructure as code. You write it, you have the pipelines, run it, you run it, get the database. In all the cases, again, you get the database, but timelines differ, the experience differ. How does usually internal developer platforms, a properly developed one, does this? You would have UI, CLI-based provisioning options, a wizard for you to click and get your resources provisioned, or even source code-based provisioning options where in your source code itself, in a meta file, in some notation, say, I am depending on a database of this type, and by the time your source code is getting deployed, it will provision the required resources on the environment as well. And usually these provisioning options that the internal developer platforms offer will support different resources and then classes in that as well. So if you take database as a resource, and then it will support Postgres, MySQL, and things like that. So with this, again, we'll look at a concrete implementation of this through Choreo. So Choreo offers you to create database servers within the UI itself. And then once this is created, it will get added to the earlier the service catalog, internal developer portal that I talked about, so that others can discover that as well. And on top of that, private beta that we're introducing is Kanchana talked about these pipelines, where infrastructure pipelines, where your platform engineering team can define some pipelines developers can use, have it available as templates, and then which developers can use themselves without writing the IAC themselves to provision their resources as well. And again, another example from that same one, Kanchan use provisioning S3 bucket flow. So in this way, now developers are empowered to get their resources provisioned. With this, let's look at our architecture diagram again. You have your databases figured out now. To give that self-serviceable experiences, now you have to have some more things in the other side. From your developer portal, you need some kind of a IAC composer. That is, you get the, excuse me, can I get the slides? So from your developer portal, yeah, thanks. You get the parameters, and your IAC composer will compose the proper IAC IAC file that is getting needed. Some templating can be. It can be the value sample that it is composing. And then it gives you to IAC runner like Argo workflow or something to run it, and then provision your database, and also add it to the service catalog service for observability. Again, very conceptual architecture. More details, Lakmal will talk about it in the session in details, how we have done that. And we can talk about it after the session as well. We are available, but I'm putting it here to give you a very high-level idea of what it takes to develop that. To the advantages slides now. With this provisioning now, you have no wait time. You can provision it yourself. Infrastructure is now governed. It is provisioned by developers, but through a control system. So it is governed. How much memory, how much disk, where the disk is provisioned, everything is governed. So organizations can govern that. And the pipelines are now commonly tested. Developers are not writing this and that pipelines. It is a set of pipelines that they can use, everyone is using. So there's less room for error in the pipelines as well. So now at this point, we have figured out the dependencies. We have figured out the database provisioning as well. Now the developer has to, Arakin and Luca, go ahead and implement their API. Now it's about deploying that in the system. That is where golden paths or paved roads, as Gartner called them, comes in. So this is where how easy it is for you to create a repo, put the code there, and get it up and running in the production comes in. How this happens in the Arakin's traditional legacy enterprises, you clone and copy from old repo, remove the files, put your new source code there, and get it up and running. It happens. It happens. I have seen that happen. Or you copy and paste from some other repo your Docker files, pipeline YAMLs, find and replace, get it working. You trial and error CI/CD configuration, infrastructure provisioning configurations, get it running. Or else in a more structured organization, you would have internal documentation on how to get this done. How you create a new repository. This is the structure. This is the sample Docker file. In some way, again, Arakin side, you can do it yourself, but there are frictions. And internal developed platforms, on the other hand, do things in a different way. They would give you create component wizards, either through UI or in some cases through CLI as well. This would govern the repo structures. This would govern the IAC pipelines that you need to create your pods, your Kubernetes services, and whatnot that you need to deploy your service. This would govern the CI/CD configurations, how you are going to configure your GitHub actions or your Argo. And this would also govern how your observability hooks are configured as well. Apart from the experience that the developer gets, because this process is governed, the base images you are using now in the world of Kubernetes are now verified, given by the system. So that part of governance comes into the picture as well. And also, when you create from this flow, your services will now get registered in the service catalog automatically as well. So that is how it is happening in the enterprise of Luca with the internal developer platform. Again, we'll look at implementation from Choreo side. So in Choreo, you have different component types that you can create. Services, web applications, tasks, webhooks, even MCP servers. A template that we provide for your organization so that you can go ahead and use that. Once you choose one of those, you get this wizard. And through the wizard, you can give your source repo. You can choose what the language it is. Once done, platform will take over. By default, CI/CD will be configured for you. You can customize that, of course. CI will then go ahead and try to build your code, right? And push that into a container registry or build artifact repository. Once CI part is done, platform will also offer the CD part, where you get your build artifact from the registry, and then you will have the chance to deploy that into multiple environments. How many environments you have, what are the workflows or rules that you have to deploy, that all can be configured other hand from the platform engineering team. But platform offers, from developers' point of view, they're just CI/CD is offered to them. With that now, we will look at our architecture diagram again. Now you have your net relationship balance deployed, right? To get that deployed in a proper developer self-service way, now you need some more components. You need some kind of a configuration orchestration service which is connected to your developer portal to get the configurations like the repo URL, the language, and create the configurations that are needed for your CI and CD systems. And that configuration orchestration service will now configure your CI and CD. Your CI will be configured to connect to your source repo, get it, build it in some way. You might be using Argo or GitHub Actions internally, and then you have to push it to some kind of a build artifact registry. In the world of Kubernetes, that would be a container registry that you are using. And from there, you would configure your CD system to pull from your artifact registry, and then to deploy to your environment involve Kubernetes to the Kubernetes cluster. So this is the updated architecture diagram after we have deployed the net relationship balance service. So Up to this point, we have covered, this is the third key capability of developer self-service. With this, when we move into advantages, now developers have to do less tasks, no writing of ISCs, organizational guidelines enforcement, because everything is running through these pipelines or wizards. You will have secure runtimes because we choose the base images. Battle testers configurations for your CI, CD, or whatnot system, other system that you need. You'd have, connected with the secure runtime, you'd have stable base images as well, because you are choosing your base images now. And default sanity checks that the organization can configure, like Trivi, Sona, whatnot. So these are the advantages that you have. So we are now talked about dependency discovery, provisioning, now golden paths. The last capability that I want to highlight is built-in observability. So now everything is deployed. Now the next thing upon mind of the developer is basically maintainability. How to maintain that? To maintain, you of course need observability. You need your logs, matrices, and traces to be working perfectly. To do that in Arakin's enterprise of a megalithic empire or the legacy bank, right? You would have to configure your observability manually, get the files, configure your Fluent bit, configure your Prometheus, whatnot, or you'd have to add sidecars to collect the matrices and publish somewhere. That is configuration part. And then about the weaving part, usually you would have to use secondary portals for you to log in and look at the logs, matrices, or traces. Or even in some cases, if you are to look at a production metrics or production level logs, you'd have to open tickets, wait for your SRE or platform engineering team to give you those tickets as well. That is how it is done in Arakin's enterprise. In Lucas' internal developer platform world, the observability will be auto-wired. So auto-wired means there will be no or minimal configs to get your observability working. Because the platform is made and you are using golden paths to create your workloads, golden path will ensure that your observability is auto-wired. You would usually get unified dashboards, a single place to look at all the three pillars of observability, and then also will get built-in alerts for you as well. One other thing some internal developer platforms or the designed ones offer is seamless correlation between different systems. So a deployment will have different components, load balancer, API gateway, and your actual workload that is running. When you want to maintain, when you want to debug something, you need to correlate between log traces of each and every one of them. So that correlation is also important. So those are some things that internal developer platforms will focus on providing. Again, customer will look at to a concrete implementation using Choreo. So this is Choreo's project level observability view. So in this, now in the same investment banking operation, so this, I don't know whether you can see, this is the new API that Luca developed for the high net worth relationship balance. It is connecting to the investment banking backend and the lending banking backend over there. That is the project architecture. That is shown in the observability view by default. It is not drawn, it is drawn automatically by the system. You can see the project level logs, and then you can drill down into the component level, which will show you things like request latency, CPU usage, memory usage, and of course the logs. So these are built into the platform based on different implementations of the internal developer platform. The views and the DX will be different. I'll throw in one other thing other than observability, which is insights. So Choreo offers several insight factors as well. In this case, I would get a screenshot of the operational insights for a CIO kind of a profile. Now you can see how many projects you have, how many components you have, what is the organizational level deployments happening, memory usage happening, things like that. There are a lot of other insights that will be available by platforms like this, right? And with this, we'll move on to our final piece of the architecture diagram. Again, very conceptual. I have boiled down everything into an observability collector, representing both metrics, logs, and traces. I know it's not the case practically, but for the illustration purposes. So you have a collector, you need some kind of a processor to process and keep it. and then you have an API which offers this data to your developer portal. Or in some cases, your developer portal implementation might choose to go ahead and directly talk to your observability processor as well. That can be done as well. So this is how our final architecture looks like. While we have done our business requirement here in yellow and orange color, the gray color ones are the supporting system that we had to have this self-service developer capabilities. With this, we'll move on to the advantages section. Now you have quick feedback cycles because you have the metrics available for you. You have inbuilt alerting, which can alert you of SLA violations and things like that. And you can do quicker issue resolutions because you have the observability configured for you from day one. Now let's look at these 3 pillars of advantages. I made them in 3 pillars in purpose. So the first column, ready-to-use information, less cross-team interaction, no wait time, less tasks, quick feedback cycles, all boils down to velocity and efficiency. Saeed from Vitality Group talked about this one, and then Kenny from Wipro also talked about this one, how they have improved their velocity by developer platform. Saeed, when asked about what's the best innovation that he had done, he said, it's the investment on the mobile delivery platform that we have done, which has increased our efficiencies by 40%. That's what the self-serviceable internal developer platforms do. They will increase your efficiency and velocity. On the second column, you have configuration governance, infrastructure governance, organizational guideline enforcement, secure runtimes, inbuilt alerting of SLA violations. All this boils down to inbuilt governance and security that the internal developer platforms with proper self-serviceable capabilities offer. Third column, less human error, common tested pipelines, battle tested configurations, stable base images, default sanity checks, and quicker issue resolutions. All boils down to stability. So these are the 3 advantages I picked which a proper self-serviceable internal developer platform will offer to you. Why these 3 advantages are very significant? These 3 advantages, or I would say properties of your organization, will help you to make your organization performing at an elite level. To connect the dots, this is DORA metrics. It's a part of Google now from 2018, and they published these 4 metrics, and then they categorize organization on like elite, great, good, like in categories based on the score that you get. So each of these matrices, so deployment frequency is a measure of your velocity. Lead time for change is a measure of your efficiency. Change failure rate is a measurement of stability, and mean time to recovery is a measure of efficiency and monitoring. If you look at our 3 pillars back, it covers most of these things. So if you are having a proper self-serviceable internal developer platform, even from DORA metric standards, your organization will automatically be in the elite level of performance or efficiency. One more factor to support that, this is actual data from Gartner's Why and How Developer Experience Drives Outcomes. They conducted research with a set of developers, and from those numbers, what they came up with, I want you to focus on left and right-hand side is 31% more efficiency. These high-quality developer experiences, I read that as good self-service experiences, most likely to improve delivery flow, and 33% more likely to attain their targeted business outcomes, which is quality equals to stability as well. Another proof that our 3 pillars are important 3 pillars that organization, enterprises should focus on. With that, I'm going to coast into the closing remarks. This is from Gartner Hype Cycle Platform Engineering 2025, just released. Treat the developer experience like a product. Assign clear accountability for delivering end-to-end developer journey to dedicated developer experience team and product owner, while enabling individual development teams to identify and address local developer experience needs. I wanted to focus on the fact that product and dedicated developer experience teams and having product owners. That is the mindset that we should have when thinking about internal developed platforms. You can buy it, you can build it. If you're buying, there's a team behind that who is taking care of that. So you have to just compare the feature set of different vendors, get your buying decision done. If you are trying to build it, you have to make sure that you have a dedicated team, a product owner who is treating it like a product, right? That is the only takeaway I want you to take from this 30 minutes.